So if you remember cookies for COVID, that first investigation that we did, the quadratic function that we got was in this factored form, where your function was actually the product of two linear functions. So you can think of these two, they weren't this simple, but you can think of these two as being two slope-intercept equations being multiplied by each other. So it's like you have a linear, a quadratic function can often be thought of as the product of two linear functions. So these are both like y equals mx plus b functions, you're multiplying them together. And so remember, this is where you have a situation like that cookies for COVID, where your variable sort of has a give and take. If you change one value, it has two different effects. So in that case, when we change the price of a cookie, then it both affected how much money you made per cookie and how many cookies you sold. So the two expressions reflected that X is sort of doing two different things at the same time, sort of has an interdependent effect on each other to produce that Y value. They call this factored form though because you have two expressions being multiplied together. And in factored form, your quadratic function is being written as what two things are being multiplied together. So think, if you have a number like 12, you could write it in factored form as 2 times 6, break it into its two pieces. In quadratic functions, you're factoring into two expressions, not just two numbers. You can factor out numbers in a quadratic pattern and everything, but when it refers to factored form, it's actually factored into two separate linear expressions. And a lot of quadratic functions can be factored this way. Not all, and when you figure out how this function relates to the features of the parabola, you might see why not all quadratic functions can be factored. So hopefully you had a chance to play with the manipulative. And notice what happens. So you start out with n is 1 and m is 1. And notice the 1 and the negative 1 for the x-intercepts. This is not a coincidence. So if I take one of these and increase the value of n, notice what is changing in the parabola. Notice that left side x-intercept shifted. So this n value is actually telling us one of our x-intercepts, but it's not the same sign. When n is 2, it has an x-intercept at negative 2. If we change the other one, the x minus m function, we change m, it shifts the other x-intercept. So if m is 3, you have an x-intercept at 3. So what these two pieces are telling us, the n value and the m value, are the x-intercepts. So in standard form, we had the y-intercept and some information about whether it opens up or down, whether it was stretched or compressed. And the b value told us whether or not it was centered on the y-axis. In this form, it's telling you what point or points it crosses the x-axis at. So I say point or points because right now I have two x-intercepts, but notice, hopefully you did this, I suggested this, make sure you make one or both of them equal to 0. So first of all, that makes it so it goes through the origin. If I make both of them 0, it now has a single x-intercept that's also the vertex and also the y-intercept. It goes through the origin. So in this case, you only have one x-intercept. So what we want to do, though, is think about why those two numbers are the x-intercepts and how you can look at an equation in this form and determine what the x-intercepts must be. So watch what happens if we assign numbers to these. I'm going to write out my equation. I'm going to have y equals x plus 3, and let's do x minus 1. So remember, x-intercepts are the values of x when y is 0. So x values when y equals 0. So let's look at our equation and think, why would these two numbers, in this case a 3 and a negative 1, tell us what our x-intercepts are? So think of it this way. If x was a negative 3, If x was negative 3 in this expression, notice it turns one of those two binomials, one of my expressions, to have a value of 0. So I now have y equals 0 times negative 4. Now that negative 4 actually doesn't matter. 0 times anything equals 0. So any x value that makes one of these expressions, either the x plus 3 or the x minus 1, equal to 0, is going to make the entire expression have a y value of 0. So on the flip side, I could also take this and, in this case, I'm going to turn x into 1. And notice what that does. Oops, that x was supposed to be 1. There we go. So notice 1 minus 1 is 0. So the other x value that turns the other expression, the other factor in this factored form, into 0 would be 1, and 4 times 0 is 0. So the reason n and m indicate the x-intercepts of the parabola is because they tell you what numbers are going to make those two expressions equal to 0. So you could say the x-intercepts are equal to, so the x-intercepts would be equal to negative n in the case of x plus n, and m in the case of x minus m. So what I'm trying to say there by the way that I wrote that is just that the x values of the x-intercepts are going to be the opposite values of that n and m. So if you have a plus 3, then x is negative 3, would make that expression equal to 0. If you have x minus 5, then it would be a positive 5. It would make that expression equal to 0, and it would be that 5 that would be your x-intercept. So looking back at the manipulative, sometimes both your x-intercepts are on the positive side. So notice in this case, let me make these nice whole numbers. So notice in this case, I have the equation would be x minus 2, x minus 4. Positive 2 and positive 4 are my x-intercepts because 2 minus 2 and 4 minus 4, both of those equal 0. So there's two ways for a quadratic function to have a y value equal to 0. And the n and m values indicate what those are. But you're looking for, when you're looking for what the x-intercepts are, you're looking for an x value that has the opposite sign of n and m.